For today's lesson, our focus standard comes from Grade 7, Number Systems, Standard 1. Apply and extend previous understandings of addition to add integers. Our topic for this lesson comes from our Adding and Subtracting Integers unit, Rules for Adding Integers, Part 1. Our essential question is, how can we use integer chips to determine the rules when adding integers? Please take a moment, pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set your question column and your note column, and resume the video when you're ready to begin. So we've already done some work with adding integers, and this week and today we're going to start finalizing our understanding of adding integers and start to generalize it to make some rules. So let's start with a few things we're familiar with. So far we've been using integer chips to add integers. We've also used number lines, but today we're going to use integer chips again to look at some examples and some patterns. So once again, the yellow side is going to represent a positive integer, and the red side is going to represent a negative integer. And there's a couple rules we've kind of already figured out. The first one we learned back in elementary school, that if we add two positive integers, we get a larger positive integer. We also have started to understand that if we add two negative integers, we get a more negative integer. And that is pretty intuitive to understand. So now let's see if we can think about some other rules that might apply. I'd like you to set up a table where we are going to look at examples of starting with a positive integer and adding to it a negative integer. We're going to do two sets. So set up a T-chart column and enough room to do 3 examples and leave some room for summary on each set. Our first problem is 6 plus negative 4. Problem B is 5 plus negative 1. And our third problem, C, is 4 plus negative 2. I'd like you to write down these problems, as well as leave room for the pattern and the rule down below, and draw in integer chips to find each sum. Once you've solved each of these 3 problems, or you're ready for a little bit of help, resume the video and we'll compare our work. Let's see how you did. For problem A, I would expect you to have 6 yellow positive integers, chips, lined up with 4 negative integers. And from our previous work, we know that 0 pairs are going to cancel out. So each of these 4 sets of positive and negative integer chips will cancel out, and our final solution is positive 2. So 6 plus negative 4 is 2. For B, 5 plus negative 1, I would expect to see 5 positive chips and 1 negative chip, canceling out this first 0 pair, and noticing that you have 4 positive left. So 5 plus negative 1 is 4. For our third problem in this set, 4 plus negative 2, we'd have 4 positive chips and 2 negative chips, canceling out to 0 pairs, leaving us with 2 positives. So 4 plus negative 2 equals 2. So as we work today, I want you to look for a pattern. Is there anything you notice that all 3 of these problems have in common? Hold on to that idea and let's take a look at the second set of problems. I'd like you to do the same thing. I've given you 3 problems. I'd like you to pause the video, draw in your integer chips, and write your solution. For our second set, our first problem is 3 plus negative 7. Problem B is 1 plus negative 4. And problem C is 5 plus negative 6. Pause the video to do your work and resume the video when you're ready to compare. Let's see how you did. For A, I'd expect 3 positive chips laid out with 7 negative chips, canceling out the 3 pairs 0 pairs, leaving us with negative 4. So 3 plus negative 7 is negative 4. For problem B, your diagram would have 1 positive chip and 4 negatives, canceling out the 1 0 pair, which leaves you with 3 negative chips. So the answer to 1 plus negative 4 is equal to negative 3. And our final problem in this set would have 5 positive chips and 6 negatives, canceling out our 6 0 pairs, our 5 0 pairs, leaving us with just 1 negative. So 5 plus negative 6 is negative 1. So are there any patterns that you notice? I specifically made the 2 sets. Set 1 has something in common with these 3 problems, and set 2 has something else in common. Notice that in set 1, all of our answers are positive. 6 plus negative 4 was a positive 2, B was a positive 4, C was a positive 2. And if you notice, the way we lined them up, we have more positives, or we have our first number is a number, an integer that has a greater absolute value than the negative integer we added to it. 6 is a greater absolute value than negative 4. 5 has a greater absolute value than negative 1. And 4 has a greater absolute value than negative 2. We see that because they stick out further in each of these examples. So what I wanted you to see, the pattern I was hoping we would see here in this first set, is that if we take a positive integer with a greater absolute value, as we did in each of these 3 problems, and we add a negative integer with a smaller absolute value, then our answer is going to equal a positive. So a large positive integer plus a negative integer with a smaller absolute value is still going to have a positive sum. What do you think the pattern is for set 2? Notice it's pretty much the opposite. Each of our answers had a negative sum, negative 4, negative 3, and negative 1. Again, we started with a positive integer, but this time the absolute value of the negative integer that we added to it had a greater absolute value. Negative 7 has a greater absolute value than 3, negative 4 has a greater absolute value than 1, and negative 6 has a greater absolute value than 5. And we see that because the negative chips stick out further. And so the rule, or the pattern for this second set, is if you take a positive integer with a smaller absolute value, and you add to it a negative integer with a greater absolute value, the sum is going to be negative. So we will be doing some more work with problems like these in class. Please make sure that your notes are complete and come ready to do some more work with integer rules while adding a positive and a negative integer.